All right, today we're going to pull back the curtain on a really powerful framework for signal research. But, before we dive into the cool tech stuff, we've got to solve a little identity crisis. What do we even call this thing?
Okay, so you might have seen two names floating around for this, RFabric and FlipperPie. What's the deal here? Well, long story short, RFabric is the official public name. FlipperPie? That's kind of like its old internal code name from when it was just a prototype. Let's get this straightened out.
And to make sure we've got it right, let's go straight to the horse's mouth, the official documentation. This is where we get the final word. And there it is, crystal clear. The documentation basically says, RFabric is the one and only public name. So that settles it. FlipperPie has officially a thing of the past, just a ghost from its prototype days. From here on out, we're calling it RFabric. Got it? Good. Okay, now that we've got the name straight, let's get to the fun part. What exactly is RFabric? So, in a nutshell, you can think of RFabric as this ultimate universal remote, but for signals. It's a software framework that lets you play with a whole spectrum of things. Radio frequencies, infrared, NFC, you name it. And the real game changer, you're not locked into one specific piece of hardware. It's what we call hardware agnostic, which is a fancy way of saying it's incredibly flexible.
So you're probably wondering, how on earth does it manage all of that flexibility? Well, it all comes down to its brilliant design, which is built on 5 core principles.
And here they are: hardware abstraction, layer isolation, capability negotiation, protocol modularity, and observability. Now, these aren't just buzzwords. These 5 pillars are the very foundation that makes RFabric so powerful and able to talk to pretty much any device you throw at it.
This stack right here is a perfect picture of that layer isolation principle we just mentioned. See how it's broken down? You've got the application layer at the top, all the way down to the physical hardware at the bottom. Each layer has one job and one job only. And crucially, it only talks to its neighbors, the layer directly above and the one directly below. This keeps things neat and tidy and makes the entire system super stable and way easier to work on.
Okay, of all those layers, there's one that's really special. This is where the magic happens. We're talking about the hardware abstraction layer, or HAL for short. And if RFabric is the universal remote, the HAL is its universal translator. So what does this translator do? It basically creates a common language. The main software up top can just say something simple, like, hey, start capturing radio signals. It doesn't need to know what kind of radio is plugged in. The HAL takes that general command and translates it into the super specific nitty-gritty instructions that whatever physical device is connected can actually understand. It's brilliant. And how does it enforce this common language? Well, you're looking at it right here in the code. It sets up a strict set of rules, a contract, that we call an abstract interface. This RF device class basically says, look, if you want to be part of this system, you have to know how to do these things. You must have a configure function. You must have a start stream function. It's not optional. It's the price of admission. And the result of that strict rule? It's amazing. A developer can write code for a specific device, say a hackref, and as long as they follow that contract, it just plugs right in and works. The rest of the software doesn't have to change at all. You could literally unplug the hackref and plug in some other completely different radio, and as long as its code follows the rules, the main system would be none the wiser. It's plug and play for radio hardware. And this translation isn't a one-way street. It works for data coming back from the hardware too. The HAL takes whatever raw data a device spits out and cleans it up, standardizes it. So no matter what NFC reader you're using, the data that gets passed up the stack looks like this, a nice, clean, predictable format. The next layer up doesn't have to guess. It knows exactly what it's getting. And it does the exact same thing for something way more complex like raw radio signals. The raw IQ samples come in and boom, the HAL packages them up neatly with all the important metadata, like the sample rate and center frequency. The big takeaway here is that the protocol engine, the layer that does the heavy thinking, is completely shielded from the messy hardware details. It can just focus on its real job, making sense of the data.
So when you see this level of careful design, this really rigorous architecture, it makes you ask a pretty important question. What's the point of all this?
I mean, is this just a super cool toy for hobbyists to mess around with? Or is it something more? Is this a serious, professional-grade tool built for real research? Well, the official docs actually give us a checklist for what separates a toy from a tool. A serious framework has to do things like enforce runtime invariance. That just means it has to guarantee that certain critical rules are never broken, no matter what, or support deterministic fallback, which means if a piece of hardware suddenly fails, the system doesn't just crash, it has a predictable, safe plan to handle that failure. These are not easy things to do, and RFabric was specifically engineered to tick all these boxes.
And that really gets to the heart of it. The key word here is engineered. RFabric wasn't just, hacked together. It was meticulously designed from the ground up to be a serious platform for repeatable, verifiable research in science and security.
And that leaves us with a really interesting thought to chew on. As these incredibly powerful and flexible frameworks like RFabric become more common, more accessible, what happens next? What kinds of new doors does this open for wireless research and security? How is this going to change the game for all of us? That's definitely something to keep an eye on.